Space is empty. You know this. You've always known it. Between your hand and the wall across the room, there is nothing, just distance, a gap, a passive, indifferent container that holds objects the way a bowl holds fruit. The bowl doesn't care about the fruit. It just sits there, doing nothing. Space is like that. It's the stage. The objects are the actors. The stage doesn't act. That's the assumption. And it is so deep, so quietly embedded in how you perceive everything, that you probably never once questioned it. Why would you? Every experience you've ever had confirms it. You walk through a room. The room doesn't push back. You throw a ball into the air. Space doesn't grab it. Things fall because of gravity, not because of space. Space is just there, neutral, waiting. I want to stay with this assumption for a moment, because what we're going to find is that it isn't just slightly wrong. It's wrong in a way that restructures every question you can ask about motion, time, and what it means for two things to happen simultaneously. And the restructuring doesn't come from a philosopher with a clever argument. It comes from a measurement, a real, repeatable, stubborn measurement that refused to behave. Here's where it starts. Galileo noticed something. He noticed that if you drop two objects off a tall structure, objects of different weight, they hit the ground at the same time. Not approximately the same time, the same time. And that is strange. Think about it. A heavy object feels more gravitational pull. A light object feels less. Why would they land together? If gravity pulls harder on heavier things should fall faster. But they don't. They fall identically. That's not an answer. It's a description. Saying gravity pulls heavier things more but they fall the same is just restating the mystery, not explaining it. Newton later formalized this. He gave you the equations. Force equals mass times acceleration, and gravitational force is proportional to mass. The mass cancels out in the math. That's why every object falls at the same rate. But notice what Newton did. He didn't explain why the universe arranged itself so that mass cancels. He just noticed that it does and moved on. That should bother you, because a universe where that cancellation is exact, not approximate, not almost exact, but perfectly exact, is a universe that's telling you something. And here is where space enters quietly and changes everything. Think about what it means to say an object is at rest. You're sitting still right now. Relative to the floor, you are not moving, but relative to the center of the earth, you are rotating. Relative to the sun, you're orbiting at roughly 30 kilometers per second. Relative to the center of the galaxy, faster still. So which of those is the real at rest? The answer that physics settled on before Einstein was, you pick an inertial frame, a frame where things that aren't being pushed or pulled just stay put or move in a straight line at constant speed. Newton's laws work perfectly in those frames. The assumption was that these frames exist, that the universe, at some fundamental level, has a preferred background structure, that somewhere there is a true at rest. Here's the strange part. In the late 1800s, physicists decided to test this. Light was known to be a wave. Waves travel through a medium, sound through air, water waves through water. Light was thought to travel through something called the aether, a substance that filled all of space. And if that substance existed, then the Earth moving through it should produce a detectable shift in the speed of light in different directions, like swimming with the current versus against it. So Michelson and Morley built an apparatus to measure exactly that difference. They expected to find it. They found nothing. The speed of light was the same in every direction, regardless of how the Earth was moving. That should bother you. If you're on a train going 100 kilometers per hour and you throw a ball forward at 50, the ball moves at 150 relative to someone on the ground. That's ordinary. That's how speeds add. But light doesn't do this. Whether you're moving toward a light source or away from it, the light still reaches you at the same speed. Every time. Always. The measurement is unambiguous. And here's the moment where the assumption about space begins to collapse. If the speed of light is constant for all observers, no matter how fast they're moving, then something else must be changing. Because speed is distance divided by time. If the speed stays fixed while the motion changes, then either distance or time or both must be shifting to compensate. The universe is adjusting something to preserve that constant. Think about what that means. The universe has a commitment. It is not going to let you catch light. No matter how fast you go, light runs away from you at the same rate. And to enforce that commitment, it adjusts space and time themselves. This is not a philosophical claim. This is what Einstein found when he took the constancy of light seriously and followed the mathematics without flinching. Two events that happen simultaneously in one frame of reference do not happen simultaneously in another. A clock moving relative to you ticks slower than a clock at rest beside you, and a ruler moving relative to you is shorter along the direction of motion than it is when it's sitting still beside you. These aren't approximations. These aren't effects that show up only at extreme speeds and can be safely ignored otherwise. They are real, exact consequences of how the universe maintains the speed of light. This is where it gets uncomfortable. Your intuition says that time is universal, that right now, as you watch this, now exists everywhere simultaneously, that somewhere on the other side of the universe, there is a moment that is the same moment you are in. That intuition is wrong. There is no universal now. There is no cosmic clock ticking at the same rate everywhere. Whether two events are simultaneous depends entirely on the motion of the observer. One person watching two lightning bolts says they struck at the same moment. Another observer, moving relative to the first, watches the same two lightning bolts and says they absolutely did not. Both are correct. Neither is more correct. The simultaneity isn't real in an absolute sense. And if simultaneity isn't absolute, then the sequence of events which happen first can also differ between observers, provided the events are far enough apart that no signal could travel between them. That means the universe doesn't have a universal past and future. It has a more nuanced structure than your brain evolved to perceive. Now go back to space, back to the assumption that it's a passive container, a bowl. Because here's what falls apart when you take all of this seriously. Space and time aren't separate things. They are two aspects of a single four-dimensional structure. And that structure is not passive. It is not inert. When you move through space quickly, you move through time more slowly, not because something is pushing your clock around, but because the geometry of space-time has a specific shape, and you are always moving through that geometry at a fixed combined rate. The faster you go through space, the slower you go through time. Not metaphorically, not philosophically, measured. Particles and accelerators live longer than they should. Muons created by cosmic rays at the top of the atmosphere make it to the ground before they decay, because at the speeds they travel, time runs slow enough for them to survive the journey. GPS satellites have clocks that tick at measurably different rates than clocks on the ground, and if engineers didn't correct for this, GPS navigation would drift by kilometers per day. These are not edge cases. These are systems that were built and calibrated around the reality of relativistic time. And now return to Galileo's result, the one that started all of this, where heavy and light objects fall at the same rate. Einstein saw that this wasn't a coincidence encoded in canceling equations. He saw that it was a structural fact about space-time, because if the geometry of space-time curves in the presence of mass, and it does, then every object falling freely through that curved geometry follows the same path regardless of its mass, in the same way that every ball rolling down a curved surface follows the same curved path regardless of its weight. Gravity isn't a force reaching across empty space. It's the shape of the space-time through which things move, and every object, regardless of mass, simply follows the shortest available path through that shape. The original question, why do heavy and light objects fall at the same rate, was incomplete. It assumed that gravity is a force acting in a passive, flat, Euclidean space. Replace that assumption with the actual structure of space-time, and the question doesn't need an answer. It dissolves. The behavior is built into the geometry. The mystery was never in the objects. It was in the shape of the space they were moving through. So what was the assumption that didn't survive this? It wasn't an obscure technical claim. It was the assumption that space is a container, passive, flat, unaffected by what it contains, independent of time, the same for all observers. That assumption is wrong on all four counts. Space is not flat near massive objects. It is not independent of time. It is not the same for all observers. And it is emphatically not passive. The curvature of space near the Earth is the thing holding you to the floor right now. What replaces the assumption is not a different assumption. It's a reframing. The question, where is this, isn't complete without and when, and according to whom. Location isn't a point in space, it's an event in space-time. And the geometry of that space-time is what every force, every motion, every measurement is secretly negotiating with all the time. That's not unsettling because it's strange. It's unsettling because it was always true. The geometry was always there. You were always moving through curved space-time. Every clock near a massive object was always ticking slower than a clock further away. None of this began when Einstein wrote it down. It was already the structure of the universe, while people assumed the opposite. And this is how physics actually moves. Not by finding new facts and adding them to the pile, by finding that the pile was arranged around a wrong assumption, removing the assumption, and watching the entire structure rearrange into something that accounts for far more than the original. Newton didn't fail. His equations are still used to navigate spacecraft within the solar system, but they were the low-velocity, weak gravity approximation of a deeper structure he hadn't yet seen. Einstein's equations contain Newton's as a special case. Whatever comes next will contain Einstein's. The universe is not obligated to be intuitive. It did not emerge from human instincts or evolved perceptions optimized for the African savanna. It has a structure, and we find that structure not by asking what feels right, but by measuring carefully and then following the implications without flinching, even when the implications are that time slows down, that space curves, and that what you thought was nothing is the most geometrically active thing in existence. That's not a conclusion. That's a door.